Hello everyone, welcome to my attempt to recreate a folding karambit. I believe it's called a Provoke, is what it's called. And they're traditionally made out of aluminum. The blade is D2 steel and some other things. This is going to be out of damascus and titanium. And the frame will be steel. The blade and the folding arms will be damascus. The kind of the belt clip on one side will be titanium. And then the locking mechanism will also be titanium. And this is about what it'll look like when it's done. So it starts out with two chunks of damascus here. Now these are scrap pieces from a previous project. They're offcuts. You always forge more than you need, and so these were two pieces I had left over, and they were the perfect size. So let's get started on drawing this out. This is a piece of damascus. I believe it's a twist damascus piece. And so I have to reduce this thickness by about half, and I have to elongate this. So the finished thickness is going to be about 0.2 inches thick, just under a quarter. And then I'm going to make the folding arms will be cut out from this one piece. So here is, you'll see me just reducing this down, reducing it down, getting it thinner, elongating it. And here it is. This is almost at its final elongation, I believe. So I'll flatten this out, and then I'll cut two little arms out of this. Now, these arms are going to be curved. They have a slight curve in them. So what I want to do is I want the pattern to flow with that curve. So in two places, after I forge it out, you're going to see I'm going to hammer a curve into where I'm going to cut these pieces out. So that'll deform that pattern and it'll flow with the arms. Each one of these arms is kind of slightly curved. So I hand hammered those in here. You can see one little curve. One end will be one arm and the other curve here for the other arm. Now this is the piece of steel for the blade. This only has about 5 or 8 layers in it, something like that. The layer count is not very high in this. It's a very bold pattern, I like to call it. On some, you can add more plates, you can cut it and restack it, and you can get an almost infinite number of layer counts. I mean, I've seen, there's videos on YouTube of people doing 1,000,000 layers, right? But this one just has, it's under 10, I believe. Very low layer count. I want very wide, bold striations on this blade. So here it is. I'm just kind of reducing its thickness, lengthening it, and I'm going to, I have to turn sideways here and widen this. It's not quite wide enough. So I have to make this a little wider before I can start drawing it out. So I finished this blade. The forging was about a 1/4 inch thick. And so you always want to have some material to remove. The dies don't press perfectly, and scale removal, there could be a little imperfection in the metal. So you always want to have enough material that you can grind back. And so at least I'm at this point now. I have to leave more material. Someone who's better at forging and more skilled at doing this than me probably can get closer and have to remove less material, but at this point in my forging skill level, I'm still leaving enough material to grind back on each side. So here as I'm drawing this blade, and I want to make sure those layers kind of converge, those striations kind of converge on the point of the blade. So I want them to kind of widen out with the width of the blade and then taper back down again towards the tip. And so here I draw it out. Now this is the forging after it's just been a rough grind real quick. And then here I am shaping the blade. I didn't include all the video of me, an hour and a half of grinding and profiling. It'd be a little boring. So these are just the finished shots of me shaping the blade. I ground a little notch in that. I radiused the back. I ground the sides parallel. So You'll see here, this is almost pretty much the finished blade shape. Now, there's two pivoting points on the blade that get drilled and tapped 1032. So here I'm drilling, this is a tap drill for 1032. Now the frame of this, I guess I'm calling it the frame, is made out of 0.175 steel plate. Now I used a recycled saw blade here. It's from a concrete cutting wall saw. So it's actually about, I think the blade, the steel is 1.180, but after finish grinding and prepping for parkerizing, I think this ended up right around 0.170. And here's the frame. Now this is going to get profiled and reduced in a few. I made it a little bigger than I needed to. This is the general shape. Now I drill this for 1032, and these get tapped along with the blade. Now these are pivoting points. They just get through drilled. So this is called a clearance drill. So these got drilled for clearance drills for 1032. And these are the Damascus pivoting arms. Now these are going to get a pretty heavy countersink in these for these 1032 countersink screws. Now you can see the countersink, the through drill, the countersink, and I did all the profiling with my little Dremel, drum here, and I scalloped the arms to kind of change the pattern. So you see after etching here, the pattern, this scalloping causes a little visual effect with the Damascus. And so this is pretty much a finished part here. There is one of these gets a locking notch cut in it for the mechanism, and the back gets relieved. So this is almost done. There's two of these. Now the frame gets tapped then 1032, and the blade does too. Now what I did to avoid a problem of getting the right, sometimes these little folding karambits can be loose, have a lot of play. I rosette welded, after I threaded these holes, I rosette welded the hole shut. And here's the pivoting arms, the frame, and the blade, all kind of mocked up. Now these are going to be cut out of titanium. One is going to be a belt clip, and the other one is going to be the spring locking mechanism. And then I will have to cut a little section and weld it onto the frame to kind of protect yourself the blade tip. So after this is mocked up, I just kind of bolted it together and I cut these notches. These notches are going to help you your thumb kind of flick it open. So I folded this in the folded position and I cut these notches, and they help you kind of grab your thumb and kind of flick it open. Give you a little bit of grip there on that back corner. And also, when it's locked in the forward position, the striations help you grab the one pivot point and retract it. You don't want to be trying to grab the blade to retract it. This thing is basically a 2-inch razor, and so it's extremely sharp. So you want to keep your hands away from the blade. So I put these little notches there. Now this is grade 5 titanium, some titanium scrap I had. So I spray adhesive my templates on there and drilled my holes. And then I clamped it to the frame. And you can see I'm wearing a respirator here. And I'm grinding this titanium in the frame so that it all is smooth and fits. And I had to do a radiusing and sanding and beveling as well to keep those edges. Those edges were kind of sharp when I was done grinding. So these titanium parts had to be profiled to fit the frame. And then I relieved the interior radius. I relieved that with a little sanding disc. Now, after all these were clamped up, I had to tap drill. So I drilled through all the items, all clamped up, with a tap drill for 632 threads. Okay. After all 4 of those holes were through drilled, then I took off the part that's going to get tapped. That's going to get threaded. And now I'm drilling for a 632 clearance drill here. So this drill is going to allow the bolt to just drop through. And then I chamfered each one of those holes after I clearance drilled. And you can see these are a flush fit, and these are 632 countersink screws. Now that that's been drilled and countersunk, now I have to tap this part, this titanium locking mechanism. I tap this with a 632 thread, and go slow with titanium and use cutting fluid. But now I have to relieve this. This is going to be a spring. Titanium actually makes excellent springs. Lots of springs commercially are made out of titanium, especially where low weight is concerned. And I'm filing and grinding the notches in this frame, and then you can see a pocket. You see right behind the two threaded holes there's a pocket. And that pocket is going to allow that spring to retract back into that pocket, so you can close it. You can see how now it just dropped. It will bolt in. It'll sandwich on the frame, and that little pocket relief allows it to drop down inside. Now you can see the arm here. The back arm, which will be heat treated, has a notch, a very precise notch that was hand filed in. And as soon as it rotates forward, the spring will pop up and lock it in the forward position. And when it rotates back, now this was a very difficult geometry. I had to sand this in. It's a ramped, so it ramps up when it locks. There's also a slight depression, so when it goes into the rearward position, almost like a detent, it locks it in the back position. Not really lock it. It's more like a notch, and the tension of the spring kind of holds it closed. And now here is, I don't have any video of me hot forming this, but I heated this up with a torch and did these bending operations in the belt clip. And then I just used a belt sander or a drum sander in my drill to polish these. Now you can see how these line up here, the belt clip shape. And I got the tension just right. This titanium is about 0.110 thick, with just under 1/8 of an inch. And I reduced the thickness right at the base there where it has to pivot. So now I put the screws through, tighten them down, and I ground them flush. So here they are. Here it is installed. And these screws have been ground flush. Now I did touch those up with a bluing compound, a cold blue, a Brownell's cold blue. Now I'm putting an entropic finish on the titanium. So if the titanium's polished to 2000 grit, I heat it to 500-ish degrees. You can see it's turning to gold here. So I get around 500 to 550 in that temperature range. And then I dip it in ferric chloride. Undiluted high concentration ferric chloride. And there's a chemical reaction that takes place after you dip it in a neutralizing bath. And this is what an entropic finish with titanium's called. And I'm shooting for blues, golds, a little bit of red veining. And it came out really good. I'm getting a few purples in there. These little lightning bolt striations. I love this finish in titanium. It's one of my favorites. The locking mechanism came out. I was trying to achieve a gradient. I wanted the color to kind of progress across it. I got close. It was all right. Now, the back locking arm gets heat treated. It's so small I didn't want to fire at my furnace. So I just heated it with a torch, dunked it in my Parks 50 oil, and I got a really good hardness. I did temper that. Now this is the blade. I thermocycled the blade to do some grain refining cycles. And then I held it at a soak time and then got a quench. I also did a tempering cycle at 250 degrees on the blade. So here's the finished bevels I'm cutting with some 600 grit paper. This is turning at a very low RPM here, so I don't get any heat. I don't want to ruin the temper or ruin the heat treat on this blade after it's been heat treated and tempered. So now I have the titanium locking thing masked up. Now you can see there's a wear mark. You can't have titanium is kind of a sticky metal, so I'm going to carbidize it here. But here's the little edge piece. I TIG fusion welded that, did an autogenous weld along that, and keep you from cutting yourself when it's stowed in a pocket or rubbed up against something. Now, this titanium locking bar, whenever you have titanium rubbing up against steel, titanium's around 35 to 38 on the Rockwell scale. And if you have a piece of steel that's heat treated, or even a non-heat treated piece of steel that's rubbing against titanium, the titanium will gall, stick, and wear. So this process here, guys, is called carbidizing. So I have a Dremel tool, a vibratory Dremel etching tool with a carbide bit, and I am running 24 volts DC current to the bit. Now, I'm basically electro-depositing carbide to the face of this titanium locking mechanism. So I get all the wear parts. The top side of this gets coated in carbide. The locking edge, all the surfaces that engage against steel, I put a layer of carbide. Now I've done some measuring on this, and from what I can tell, the carbide is only 1 to 3 thousandths thick. That's 0.001 to 0.003. So somewhere between 1 and 3 thousandths. So it's not enough to build up an edge. Say you had a frame lock knife that was, was worn or something like that. You couldn't just add carbide to build up that difference, right? It's very thin, but it's electro deposition basically. So 24 volts DC current, and it deposits carbide to the face of the titanium. Now here's the finished frame. There you can see the pocket that was machined, the through holes for the belt clip. Now you can see how those holes are welded shut on one side. Now, I did get some discoloration. So this is a Parkerizing solution. It's heated to 185 degrees and you immerse. It only works for steel or any ferrous items. But here it is after it's out. Now after you take it out of that, you dunk it in oil displacement oil. But you can see the discoloration from the rosette welds there. It's unavoidable. Now here's the arms out of the etch tank. I just finished etching these. And look at that, guys. I love this pattern. You can see how the scallops kind of distort that pattern. And that's kind of what I was looking for there. And I really love how the pattern kind of morphs. And I should have actually ground that one scallop a little deeper on the opposing side there. But the blade came out really beautiful. I wish I could have got a little darker etch, but look at the polish. I took the blade to like 3,000 grit. And you usually don't polish that good, that high a level for a Damascus, but I really wanted to see like a mirror finish. But here it is, guys. This is all done. This thing functions flawlessly. And I mean flawlessly. There is zero play. Zero. It doesn't fold. It kind of locks back. It locks open easily. There is no play, no slop in those connections. The weight is really nice. Now those are some number 10 bronze washers that I'm using there. And you can see the carbidized lock frame from the titanium. There's no play in this. None. At all. Now, you can see the discoloration in the Damascus from the weld, how I welded those holes shut. But what those do is allow you to torque those nuts, those screws there. You can torque those down to you cut them to a precise height. And that's how you don't get any play. They also don't loosen. Those 1032 bolts are torqued in place. And I put a drop of thread locker on there. But this piece came out phenomenal. I did a mirror polish on the Damascus. The black frame is Parkerized. The titanium, this entropic finish is just beautiful. There's no play in it when it locks back. There's no play when it locks forward. The belt mechanism. I carried this around for a couple of days, and it actually fits in a pocket really well. It opens effortlessly. It doesn't. It kind of locks in the back position. There's a that spring-loaded D10 and that little notch in the back arm keep it locked back. Tell me what you think, guys. Let me know in the comments. I appreciate you watching. See you on the next one.